Today we're doing the factoring handout worksheet, and there's a lot to learn. And this topic is extremely important. In fact, um, this idea will be in algebra as far as you go in mathematics. So if you branch out and do like geometry or statistics or data analysis or finance or something like that, those are not algebra based. But if you take calculus or anything beyond calculus that is heavily um, reliant on algebra, what we're going to learn today will follow all the way through. It is extremely important. And the nice thing is, it's really not that difficult if you learn it the right way. So, look at letter A on this worksheet. And I have x equals 4 and x equals 3. Okay? These are called roots. They're also called zeros. They're also called solutions. They're also called x-intercepts. Why do they have 4 names? Well, because they are so important. And each name is a different way to describe what its use is. So when you get in higher mathematics, you are going to be dealing with polynomials that have lots of ups and downs, like this, and many places where that graph crosses the x-axis, which is why they're called intercepts. Okay? They're also called zeros because those are the points where y equals 0. They're called solutions because those are the numbers you can plug into the equation and get an answer of 0. And they're called roots because those are the numbers we can use to build this graph. So you can quite easily build a graph that fits any shape you want it to within certain parameters. Okay? And that's sort of what we're going to start with today. I want to build a graph that hits the x-axis at 4 and at 3. How many graphs are there that hit the x-axis at 4 and 3? An infinite number. So I am going to find the simplest version. Okay? So they're called roots because we can use those numbers to grow an equation. And here's how we do it. We put zeros on this side. So follow along with me. Go ahead and write this on A. So I'm going to move that 4 over, and I'm going to get x minus 4 equals 0. And then on the other side, x minus 3 equals 0. Okay? If I don't do this, if I were to replace this with y, and I were to graph y equals x minus 4, that would be this graph here. And if y equals x minus 3, that would be this graph here. And the cool thing about it is this graph hits the x-axis at 4, and this one hits the x-axis at 3. Right? So I just grew a graph where one of them hits the x-axis at 4 and the other hits the x-axis at 3. Okay? But I want a single graph that hits both places. So what we do, and you are going to write this as well, is I'm going to take x minus 4 and I'm going to times it by x minus 3. Okay? Now, we just spent yesterday doing that. We're going to multiply this in a strange way. We're going to use the box. Now, you guys are smart enough, you don't need to use the box, but we're going to use it on this paper just to see some mathematical patterns that we can use in the future. So I'm going to draw a 2 by 2 box, and put x minus 4 on one side and x minus 3 on the other side. And Addie, if you want to do this a different way that your mom teaches you, that's fine. She doesn't like this method. That's okay. And nobody can be perfect, right? So I multiply that out. X times x is x squared. X times negative 4 is negative 4x. X times negative 3 is negative 3x. And negative 3 times negative 4 is 12. And these are common. So I get x squared minus 7x plus 12. And then it doesn't really matter today, but technically we should put a y right there. Okay. We have just built an equation that hits the x-axis at 4 and at 3. This equation is an x squared equation, and we call that a quadratic equation. Yeah, I know, quad is 4, x squared is 4, but if you had a square with x on one side and an x on the other side, the area of that would be x squared. So we call it a quadratic. Okay. What does that quadratic look like? Well, all quadratics are U-shaped. So this quadratic looks like a U that hits the x-axis at 3 and at 4. And I'll show you what they look like. So if I type in x squared minus 7x plus 12, and I graph it. Oh, I better zoom out. There we go. That shape is called a parabola. The graph of all x squared equations is a parabola. Now remember how we did a couple days ago, we did degree and leading coefficient. Degree is the highest exponent. If the highest exponent is a 2, then your graph is a parabola. If the leading coefficient is positive, then your parabola is a smiley face. If your leading coefficient is negative, then your parabola is a frowny face. That makes sense? Okay, that's why degree and leading coefficient are so important. Degree tells you the basic shape, and leading coefficient tells you the direction. Okay. So I'm going to answer those 4 questions underneath. So in the simplified equation, what is the number in front of the x term? 7. What is the sign in front of the x term? Negative. So you could put negative 7. That's fine. Yeah, either way. What is the constant? What does constant mean? It means it doesn't vary. It doesn't have a variable. So what is the constant in this case? 12. And what's the sign in front of the constant? Positive. Now that's going to be important. So I want you to go through and do the same thing for B, C, and D. I'll pause the video. You finish B, C, and D, answer the questions underneath, and we will do E together. Go for it. These are the equations that you should get for A, B, C, and D. And now look at E. What does the last sign tell us about the factors? So if I focus in on this, 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 and this, what patterns do you notice? Why are some of them positive and some of them negative? Oh, so if the roots have the same sign, then what's going to happen? Then the constant will be positive. And we could look at either the roots or the factors and build our rules, and it turns out it's better if we look at the factors. So instead of viewing the roots, I'm going to look here. And if the factors have the same sign on the inside, then the constant will be positive. So write that down. If the factors have the same sign then the constant is going to be positive. So that is the first question on E. If the factors have the same sign, then the constant is going to be positive. What about the other two? What about this one and this one? If the factors have opposite signs, then the constant is going to be negative. If the factors have opposite signs, then the constant will be negative. Look at the second part of E. What does the middle sign tell us about the factors? So if we look at the middle sign, negative here, positive here, and positive here. This pattern's a little bit harder to see. Does anybody see a pattern? Yeah, it has something to do with the bigger. Okay, so we have to divide this into two groups as well. So if the signs are the same, right? If the factors have the same sign, then the middle term tells you what that sign is. So if we look at A and D, A and D have factors that have the same sign, and the middle sign of the quadratic tells you what that sign is. So on the second part of E, if the signs are the same, then the middle term determines that sign. So if the sign of the two factors are the same, then the middle term tells you what the sign is. All right, what about the other two? What does this tell you, and what does this tell you? What was Beckham saying? If the signs are different, then the middle term tells you which one is bigger. So if the signs are different, then the middle term will tell you which sign is bigger. All right. Now, why do we care? Well, lots of reasons, but we're going to start with the basics. So, let's say I had, this is the bottom part of E, x squared minus 7x plus 12. That is my quadratic. The goal is to figure out where does this quadratic hit the x-axis. So we need to unmultiply those two factors. And we're going to pretend like we don't know what those two factors are. We do, right? This is A. So the answer is going to be 4 and 3. So draw a multiplication box. And I need to squeeze this into that box. But it's going to take a little bit of work. Is there anything I absolutely know about this multiplication box without doing any calculation? I know that the x squared has to go in the top left box. I also know that the 12 has to go in the bottom right box. So put in x squared and 12. Now the question is, what goes in the other two? And you might be able to figure it out, but for now, we're gonna work this out the long way until you get good at it, and then we'll teach you a shortcut or two. Okay? So these two have to add to be negative 7. But they also have to multiply to be 12x squared. So we're going to take x squared and 12 and multiply them together, and I'm going to write it over here to the side. 12x squared. Okay. Now, I'm going to write down all of the factors of 12 in order. Well, all of the factor pairs of 12. So 12 can be written as 1 times 2, no, 1 times 12, or 2 times 6, or 3 times 4. And then the next one would be 4 times 3, which we already have. Okay? And each of those needs an x. 1x, 12x, 2x, 6x, 3x, and 4x. Okay. What about signs? This is positive. So what does that tell me about the signs here? Either they are both positive or they're both negative. That comes from the first row on E. So they are either both plus or both minus. How do we figure out which one it is? So this tells me they are either plus plus or minus minus, and this one tells me they are both negative. So I'm going to go through and make each one of those negative. All right. Anybody confused? All right, so how do I multiply two numbers and get a positive? They both have to be positive or they both have to be negative. So we need to figure out which one it is, and we look here to tell that they're both negative. Okay, so the numbers that go in these two boxes have to add to be negative 7 and multiply to be 12x squared. Is there a set that will work? Negative 3x and negative 4x, right? Negative x and negative 12x don't work. They do create 12x, but they also do not create a negative 7x. So this is part of my solution method, and they have to go in the other two boxes. Is it going to matter which one I put in each box? No, it doesn't matter. So I will put negative 3x here and negative 4x here. Okay. Now, we look at the first row. What do those two terms have in common? An x. So I'm going to yank out an x. When I yank out an x from x squared, what's left? X. So this is an x. When I yank out an x from a negative 3, what's left? Negative 3. Oh, from negative 3x, negative 3. And now I'm going to yank this x out of these, which that one's already done. When I take an x out of negative 4x, what's left? Negative 4. This is one of my factors, x minus 4. And this is my other factor, x minus 3. That is called factoring quadratics. And it is something that will follow you as far as you do algebra. Okay? It never goes away. It is so, so, so important. All right, what if I wanted to find the roots? How do I turn this into a root? Well, remember they're called roots, zeros, solutions, and x-intercepts? So they're called zeros because we want to know when does the equation equal 0. So I just write x minus 4 equals 0 and x plus 3 equals 0. Oh, wait, that's a minus. So x equals 4 and x equals 3, and we're right back where we started. Okay. Now, as you go through this chapter and forever on, sometimes you will be given a quadratic and asked to factor it. Factoring means turn this into this. Okay? But sometimes you will be asked to solve. And that means turning this into this. So factoring means just break it down into two binomials. And solving means break it into two binomials and then find the roots of, or the zeros of each of those binomials. Okay, one down. Let's do another one. X squared, which one was B? Plus x minus 12. Wherever you got room. I don't care where you write it. So we draw a box. The first step is put in the x squared and the negative 12. Multiply those together. Negative 12x squared. Write down all the factor pairs of 12. 1 and 12, 2 and 6, 3 and 4. But they also need x's. So it's 1x, 2x. Anyway, all of them get x's. What about the signs? What do I know about the signs? Well, what does this tell me? One of them is positive and one of them is negative. How do I figure out which is which? Well, when these two numbers fight it out, the bigger one always wins, right? When you take a positive number and a negative number and you smash them together using addition, the end result will always tell you that the bigger number wins. And in this case, the bigger number is negative. So I can go through and write plus on the left and negative on the right. That makes sense? Okay. Now, is there one of those number sets that will create a negative 1x? That would be this one. So 3x and negative 4x. And again, it doesn't matter where you put those. Okay. What does the top row have in common? X. So we yank out an x. And when I pull an x out, what's left? X plus 3. And now when I yank an x out of the first row, I'm left with x minus 4. Then we write those as factors. X plus 3 and x minus 4. What would the roots be? X equals negative 3 and x equals 4. Is that what we started with in B? Yeah, it is. Okay, let's do C. X squared minus x minus 12. So I draw the box, put in x squared and negative 12, multiply those together, negative 12x squared. I write down all the factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. All right. Again, they all need x's. What about signs? What does this tell me? I have a positive and a negative. What does this tell me? Oh, did I get that wrong? That should be a plus, right? Sorry. No? Oh, I did B wrong, didn't I? I'm sorry, guys. So This should be a plus because I'm on the other side, but anyway, I messed that up. Okay. So now I know that the signs are different and the bigger one is positive. So minus, plus on all of these. Which one gives me a plus 1? That would be this one. So negative 3x and 4x. Okay. So we pull out an x. What's left? X minus 3. We pull out an x, and I get x plus 4. So my factors are x plus 4 and x minus 3, which means that my roots are negative 4 and 3. Okay, it looks like you guys have all run out of room. All right. So let's do some that are not on your sheet, just to make sure you understand. What if I had x squared minus 8x plus 24? So you don't have to write this down. Just watch to make sure you understand what's going on. So I put the x squared and the negative 24 in place. And then I multiply those together. And I get negative 24x squared. And then I write down all the factor pairs for 24. It is positive 24. Thank you. Negative 24 will not work. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and 5 doesn't work. Now, what about signs? What does this tell me? Signs are the same. And what does this tell me? They're both negative. Now, when I do this, I don't write the x's. I just remember that I need to put x's when I stick this into the multiplication box. Is there a set of these factor pairs that add to be negative 8? No, there's not. What does that mean? Well, what do we call it when a number doesn't factor? What do we call a number that has no factors other than 1 in itself? It would be a prime number. So this is a prime quadratic. What does that mean? Well, it's kind of complicated. It means one of two things. Either the parabola misses the x-axis entirely. It's a u that's above the x-axis. Or it hits the x-axis, but at a really nasty number, an irrational number, like the square root of 2. Okay? So it might have x-intercepts, it might not. But if it does have x-intercepts, they're not very nice. Now, I made 2 mistakes when I wrote this. So, but whatever. We ran into a prime one. That was my fault. Let's do x squared minus 6. No, let's not do that. Let's say x squared minus x minus 20. So I stick in x squared and negative 20. Multiply those together. Negative 20x squared. What are the factor pairs for 20? 1 and 20. 2 and 10. 3 doesn't work, so we skip it. 4 and 5. What do we know about the signs? This tells me they are different, and this tells me the bigger one is negative. So we'll put negatives over here. Is there a factor pair that gives me negative 1x? 4 and negative 5. So 4x and negative 5x. Pull out an x, and I get x plus 4. Pull out an x, and I get x minus 5. So my factors are x minus 5 times x plus 4. What are the roots? The roots would be 5 and negative 4. Okay. All right, turn the page. Look at F. Let's draw the box for F. X minus 3 and x plus 3. So go ahead and write this out. X squared minus 3x plus 3x minus 9. And that turns into x squared minus 9. Okay, on the other side, we have x minus 4 and x plus 4. We fill that out, and I get x squared minus 16. Okay. So in the simplified equation, these are below f and g, and scratch one side out. We only need to answer these ones. What happened to the middle term? Canceled. Why? It ended up being 0, but why? What about the roots made it equal 0? There was no bigger number. You had a positive 3 and a negative 3. You had a positive 4 and a negative 4. And when they fought it out, you get 0. So the roots were equal distance from 0. Okay? So in H, what is the middle term? 0x. Why is the last sign negative? Because you had one positive root and one negative root. Okay. So these quadratics have special names. Okay, and you don't need to write this down. So these factors are called conjugates. Conjugates are factors that are identical with one sign change. So anytime you have two factors that are exactly the same, but the sign in the middle is different, then you get conjugates. And conjugates are our friends. They make multiplying binomials super, super easy. Because I only need to multiply this one and this one. I can skip the other two. Why can I skip the other two? Because I know they're going to end up being 0. So this ends up being x squared minus 9. And this has a specific name. It is called a difference of perfect squares. Or a difference of perfect squares. These are by far the easiest quadratics to factor. However, a lot of you will not remember the rules and you will miss these on a test. So don't, because these are easy. Why do we call them a difference? Because you have one term minus another. Does it have to be a subtraction? Yes, it does. And both terms have to be perfect squares. So this is x squared, and this is 3 squared. So if I had x squared minus 25, how is that going to factor without doing any work? It's just going to be x minus 5 and x plus 5. Right? Let's make it a little harder. What if I had 36x squared minus 1? Does it have a subtraction? Yes. Is the first number a perfect square? Is 36x squared a perfect square? Yes. Of what? 6x. Is 1 a perfect square? Yes. Of 1. So this ends up being 6x minus 1 and 6x plus 1. All right, let's make it a little bit harder. What about 49x squared plus 81? What is that going to factor into? Seven x minus 9 and 7x plus 9. Does that work? No, it doesn't work. Remember how I told you you'd get some of these wrong? This is your first one. What's wrong with this? So negative 9 times positive 9 is negative 81. Okay, so that didn't work. What if I change this to plus 9? Will that work? No. Now the middle term does not cancel. Do you see that? What if they're both negative? Will that work? No, because now the middle term doesn't cancel. So what is wrong with this equation? It is not a difference. So in order for the difference of perfect square factoring to work, to break down into conjugates, it has to be a subtraction. If it's not a subtraction, it doesn't work. Okay? All right. What time do we get out of here? What? Oh, we got time. We got time. Okay, turn the page. What if we had 3x squared minus 7x minus 6? Okay. This time I have a leading coefficient that's not 1. These are a little bit harder than the ones that we've just done. The method is exactly the same, but when you see them in the future, these are a little bit more difficult. So I stick in 3x and negative 6. Okay. I multiply those together, and I get negative 18x. Oh, that should be a squared. Negative 18x squared. Then we write down all the factor pairs for 18. 1 and 18, 2 and 9, 3 and 6. 4 doesn't work. 5 doesn't work. So we're done. Okay. What does this tell me? Signs are different. What does this tell me? The bigger number is negative. Good job. So we put negatives over here. Is there a number set that will give me a negative 7x? 2 and negative 9. So I put in 2x and negative 9x. Oh, actually, let me do it the other way around. So negative 9x and 2x. And here's where it gets a little bit more tricky. What do those have in common? A 3 and an x. So I pull out a 3x. What's left? X minus 3. And then I take an x out of this column, and I get a plus 2. So my factors are 3x plus 2 and, oh, not 3, x minus 3. Okay. What about the roots? Well, this one is easy. What's the root over here? 3. This one's a little bit harder. How would we find the root for 3x plus 2? Well, we would set it equal to 0 and solve for x. So if we take 3x plus 2 and set it equal to 0, we subtract 2, and we get 3x equals negative 2, and then we divide 3, and we get x equals negative 2/3. So, if you have a leading coefficient, in most cases, that leading coefficient will create a fraction when you factor. There is an instance where that's not true, but for the most part, when you factor a quadratic with a leading coefficient, one that doesn't divide out, then you will end up with at least one of your roots will be a fraction. All right, that's everything you need to know for this worksheet. Get to work.